I'm Patrick Olivier. I'm the leader of the Digital Interaction Group in Culture Lab. We're essentially the technology and interaction design partners on the project. So ambient technology is this vision of the future where sensors and displays and technology is embedded in the sort of very fabric of the world around us. So essentially that technology can monitor the human occupants of those spaces, reason about what they're doing, and hopefully provide people with the situated services that they need to support their lives, whether it's work or just living or learning in this case. So the ambient kitchen is an instance of this notion of ambient technology where the sensors are embedded actually in the tools in the kitchen and in the environment. So we have RFID sensors in the benches that can track food. We have accelerometers in the knives and the utensils that can track your actions. So it's a nice sort of microcosm of ambient technology. And kitchen's quite an interesting place because it's somewhere where we work. We do a lot of distinct actions and we can track those actions and try and understand the sort of cooking that people are doing. That has a range of applications, not just in language learning, as we've talked about in the project, but also in supporting people with dementia by giving them situated prompting when they're preparing food and drinks. We also use it actually to measure people's cooking competence. So the idea of using the ambient kitchen for language learning came through our collaboration with Paul Seedhouse, who's an applied linguist interested in task-based language learning. So this is the idea of learning a language while you're engaged in doing some meaningful task and the benefits of embedding language learning in a task. This is something that's very hard to do in a classroom situation, in the sense that you're trying to achieve the realism of the task that you're actually engaged in. And the ambient kitchen is really probably the first real-world deployment of task-based language learning where we use digital technology to actually support the learner's progress through a task while they're learning a language.
The research questions that we're asking, first of all, are the users of the French kitchen able to follow the instructions and cook the envisaged meal? Secondly, what type of interaction is generated by use of the kitchen? Thirdly, which aspects of the French language are required by users? Fourthly, this is an interesting one, can the learners learn two sets of skills simultaneously, cooking and French language? So we've got two settings for the experiments that we've done. The first one is here in Newcastle University, where as you can see we've got a fully developed digital kitchen. And we've also developed a portable version which we've used in Newcastle College, and now we've put together catering students and French students to work together. Okay, so what we can see in this extract is the two people. You've got a male catering expert and a female French student, and you can see they're both teaching each other the skills that they know. So first of all, the male catering expert is explaining how it'll break up if you give them a mix around. You can see her doing that.
Mélanger ces ingrédients et réaliser un puits dans la farine.
When you mix them, you've got to make a hole in the centre.
Well in the centre.
Yeah.
You need to break them up.
Is that?
Yeah, they'll break up once you just give them mix around. What's mix?
Mélanger.
Mélanger. Mélanger of.
When we were designing the task, we created step-by-step instructions of how to prepare the dish, together with relevant feedback. So the cooking task instructions were created in such a way as to target specific words. For example, nouns related to equipment or food, and also verbs related to cooking actions like to mix or to weigh or to cut. So the pre-task involved a dual focus on cooking and French, and this was divided into a presentation and a preparation. So the learners watched a purpose-made video recording of a native French speaker making the chosen dish for the project, which was a clafoutis au poire or a pear clafoutis. And then they were presented with a slideshow of the different utensils and ingredients they would need to make the dish, and this was accompanied with the French vocabulary. So the final stage of the preparation involved listening to the kitchen, who verbally communicated what ingredients were required to make the dish and how much of each ingredient was required.
Pour préparer votre clafoutis, vous aurez besoin des ingrédients suivants. 100 g de farine,
And at that stage, the learners also had the opportunity to request feedback using an interactive screen, such as a translation in English or a repetition of a specific word.
Beurrer un plat allant au four. Éplucher, dénoyauter et couper les poires en quartiers et en tranches. Saupoudrer le fond du plat d'un peu de farine et de sucre. Il vous faut un peu de sucre. Travaillez bien la pâte pour la rendre légère et éliminer les grumeaux.
Beat the batter firmly to make it light to get rid of the lumps.
Éplucher les poires.
Ah oui, c'est ça, le couteau éplucheur. Très bien. Tu veux le faire? D'accord. The post-task, or the things that the learners did after they'd performed in the cooking task, we used as our own kind of research tool, that is to collect linguistic data, and it was also served as evaluation from the point of view of the learners being able to talk about what they've learned. So the post-task was actually a series of exercises that the learners did to identify the key vocabulary and the key words that were used during the tasks.
Hi, I'm Dan Jackson. I've been involved in transferring the technology from the ambient kitchen to the French digital kitchen. That work has involved taking bespoke sensors that we developed and using them for language learning. The sensors that we've developed are small radio transmitters which use a sensor on board called an accelerometer, which measures acceleration in 3 axes. These little devices go inside and are encapsulated in a small unit with a battery, and they can be recharged and used for around 6 months. They get placed inside handles of utensils, and then when the utensil is moved, we can actually receive that information on the computer side and determine what's been done with the utensil. For example, a spoon could be used for stirring or for scooping. So here we can see the system identifying on this signal here that I am currently stirring the spoon by looking at the waveform of the data coming in. You can see the waveform looks fairly even here, and the computer's identified that I'm stirring the spoon. If I scoop instead, the pattern changes, but the computer's still able to identify that I'm actually scooping now rather than stirring. So we were able to then take the information from the activity recognition layer and use it to inform the prompting system. For example, if the user is asked to slice pears and the system detects slicing motion, then it can infer that the user has actually gone along with that action. If it doesn't see any slicing, then it might be able to prompt the user again or to translate the request into simpler language. We've been able to adapt the technology we've used in this kitchen and turn it into a small portable unit. This might be able to be used in schools or other learning contexts.